All right, so I didn't bore you guys with taking this thing all apart and getting the paint off of it. This is I think it's a Chinese shear, just because of I just recognize the castings and the way that you see the way that they do the adjustment for the middle of the blade, and they always are covered in this sort of white Bondo material. But I've had to do some fabrication as well. I had to make some washers for the blades. The blades look like they're in good shape. There's one spot right here that's kind of a ding, but it's on the top part of the blade, and shouldn't matter. But everywhere else, it's in pretty good shape. So happy about that. Found a bunch of stuff that like I think it was cracked here before. Obviously this is all weld. But whoever did it did a decent job the way they beaded it in. So it's acceptable, and the blade is in good alignment, so it's a good repair. This right here was a weld repair. I just kind of ground it down a little bit just to kind of get an idea if there was any porosity in there or anything. It looks like it's a fairly good repair, so I'm happy. You know, nothing wrong with that. The sear was repaired, and it was actually brazed. And this was a ton of braze on here. There was twice the amount of braze that was on here. I ground it down. But they did a good job. It was well done. So not too bad. But this sear part, it looks like they built up weld on here at some point. I've ground this down and cleaned it up a bunch. There was a bunch of burrs, and but I don't know, I'm gonna see how this works on there. I may end up probably replacing this part, fabricating something new for that. But it's not that bad. So it's kind of what it's looking like. Got just a ton of parts over here to work on, and but I wanted to make sure that the blade was going to be, you know, I wanted to make sure that it was a viable machine before I kind of took it any further. And it is. It's gonna work out good. It's gonna be a good shear. When I saw it run, when I bought it at the guy's house, I saw it run, and it ran, but it was really sloppy, and you know, it's gonna require a lot of work. I'm gonna have to machine a bunch of parts. So I gotta machine the pins that go through just here. There's a pin that goes through there. They're bent and sloppy. One right here on this side as well. That's gonna need to be replaced. This is the kind of the clutch assembly, and the other half of the sear. This is what engages that finger thing. And the spacer that they had behind there just lives down in there, and this is what they were using for a spacer, so I'm gonna have to machine a part for that. Just the key for the flywheel. This probably gonna have to, I'm just gonna refabricate this whole piece probably. You can see where they've welded here, and again, the welds are fairly okay, but it's cracked right there. That tube is cracked, and I was going to weld it, but then I just said, no, you know what, I'm gonna take it apart, probably do a little better there. Again, these are the welds. I mean, there's about, you know, 15 pounds of wire right there. It's just totally unnecessary, and truly more weld doesn't help, right? So like, all you're doing when you're adding bead on top of bead like that in such a small gap, you don't need that much. You just need a fillet weld here, because otherwise all the rest of the metal around there is getting heat affected and getting brittle, and this thing takes a pounding, right? So it's just, I'm gonna refabricate this whole part. Okay. Okay, so I was just getting ready to remake these pins right here, and this one's okay. It's tight all the way through, and this tie rod end is still in good shape. And then I went over to this side and found that this pin was bent, and I didn't understand why at first, but now I understand that because this pin, or this tie rod end, is wallowed out. Let me see if I can show you. Right, so there's so much slap in there. That constant slap bent this pin. Now, the holes on this cast are good, and it holds that, I don't know, I think it's 9/16 pin, no problem, except that this hole is too big. Now, lots of ways I can do this. I can fill this hole with weld and then re-drill it, or I can machine a piece, right? Machine this piece, machine flats on it, and remake this piece. Or I could drill this out to 5/8 and then drill the casting out to 5/8 as well. Not really sure what I'm gonna do. I'll probably end up just I'll probably just machine a new piece. I'll just machine that and then have it done, and that'll just require flats on all 4 sides with a hole, and then a threaded hole on the bottom. They just welded a nut on here, but I'll probably just drill and I'll just drill and tap it, which is what I think I'm gonna do. So here's the flywheel, and this is the, I don't know, I'm calling this thing the Shear. It rides on this flywheel like this, and then the spring-loaded pin pops out of here and it engages this sort of clutch mechanism. I'm gonna put this part on and see where the deficiencies are. You can see where this is pretty chowdered, right? This end's just chipped right off. These are all mushroomed out. It's and honestly, these cap head screws are right through, and I don't know if that's part of the design to have it be like that, or if it's just from this thing riding on this, for years, and it just wore through there. There is a thickness down here. This diameter is a little bigger, so I'm not really sure. So what I'm going to do is I'm going to kind of use it. I'm going to put it back together the way it is and see what's going on and what's wrong. I may take these off before I actually put it back together. Take these off, take this one off and flip it over, put it on this side, take this one off, flip it over and put it on this side, because the ends on the inside are probably pretty good. They look okay. So that's that. Here's all just the little parts and pieces, just kind of provisionally cleaned right now. And yeah, so beeline motor, make a beeline to somewhere. At least it's not making a beeline to the scrapyard. So yeah, these springs are just chowdered. They're gonna have to be replaced. Oh, also on the flywheel, there's a spot for 2 belts, right? It's a 2-belt system. This one only has a single belt pulley. I'll probably make a new pulley or get a new pulley, whatever. So I can run 2 belts on there. Yeah, what else can I say? This is the plate that originally held the motor. Well, this is the plate that somebody put on here, right? So there's holes in the cast here, and it's just, that's what was held on. These 2 bolts is what held that whole motor on. And then the motor was bolted right to the face of this thing. And then the pulley ran down to the drive shaft there. I think I'm probably gonna make a new plate system that's gonna go from both legs. that's going to be a little bit more substantial. There's not going to be so much wiggle and slap, because this thing wiggled and round and slapped a lot, and it's just because it's just got that one fillet weld on both sides, and you can see this plate's already deformed and bent from being used and abused. So I'll probably end up making a plate out of this this 1/2-inch stuff here. I got enough of that, and I'll make a whole new holding mechanism. But yeah, so that's the story. So I think, just like I said, the next thing I'm going to do is go ahead and make this part and have that done and over with. But look at how much that bent that like a banana. So we'll get that done. But that's where it's at so far.